We have a lot of tropical forcing, a super El Nino, the Indian dipole is extremely high. Do you think there's some implications with the extreme tropical forcing in the Pacific that could overwhelm any cold signals across the US?
It's a very good question, and it's certainly one that's plaguing any long-range forecaster. So, an interesting component about having a strong El Nino is that typically, at least according to large model simulations, when we have an El Nino event, we usually get more wave activity coming out from the troposphere that can lead to a weakened polar vortex and an increased risk of a sudden stratospheric warming event when the vortex breaks down. What we don't see in observations is necessarily that El Nino does actually drive significantly more sudden warmings. And certainly in recent years, we've had a lot of sudden stratospheric warmings in La Nina winters. And so that causality is a bit difficult to unpack. Certainly having an active El Nino or La Nina event seems to increase the risk of a sudden stratospheric warming. But in the absence of that happening in the stratosphere, and El Nino tends to drive a specific pattern across North America that often leads to generally warmer than normal conditions and an absence of significant cold air outbreaks on average. And so you kind of have that competing influence of whether one pathway, this pathway into the stratosphere, can happen, or whether we're just going to look at this kind of tropospheric pattern that leads to warmer conditions.
Yeah, so even if we have a weak polar vortex, that does not necessarily mean that we're going to have some colder outbreaks into the US. And if we have a stratospheric warming event, which historically can produce a major cold outbreak in some part of the northern hemisphere and it rotates through, if the stratosphere doesn't talk to the troposphere, a stratospheric warming event can have absolutely no implication on our temperatures, correct?
Yeah, certainly there's a lot of variability from one sudden warming to another and one winter to another. And if you think of the last few winters, we had major sudden warmings take place in February, even of 2023. And in January 2021, which was famously followed by the severe cold air outbreak that influenced, that hit Texas. But if you think of the one that took place in mid-February 2023, not really historically cold and snowy weather followed for anywhere, particularly in the Western world, and so that clearly just demonstrates that they're useful on average, and they do tell us something more than we would know otherwise. But it can't be thought of in this kind of deterministic weather forecasting sense, I would say.
Now, if the stratospheric polar vortex does stay unusually strong and does not weaken in December, let's say it stays strong for the entire winter, and we get a sudden warming event in the spring, then would you say there's a pretty high probability during that major warming event in the spring that it could drive a tropospheric pattern that would unleash cold air in parts of the US?
I think so. This is a really interesting part of this discussion is that if we don't see a sudden warming during the core of the winter, that we're potentially more likely to see essentially what's called a dynamic final warming, essentially a sudden stratospheric warming that happens in the springtime, and that can lead to basically winter having a long tail. The most recent dramatic occurrence of that was actually one that took place in early March 2016, and that was followed by some cold air outbreaks in North America and in Europe. And so that is something to think about, is that if the vortex doesn't break down at any point during the winter, then you do increase the risk of this sort of thing happening at the end of the season, and then getting the cold air outbreaks maybe when people don't want them as much as they would otherwise.
What's usually the lead time when seeing a weak polar vortex signal or a stratospheric warming event? Is the lead time about 7 to 10 days before you can really pinpoint it and say with accuracy, like a 70 to 80% chance that, hey, this is going to happen?
So for sudden stratospheric warmings themselves, when the west to east winds reverse to easterlies in the stratosphere, those events we can generally forecast within about plus or minus 3 days of when they actually occur, about 2 weeks before they do. Sometimes less, sometimes it's about 10 days, sometimes it's about 14, 15 days. In terms of actually just knowing that the vortex is going to be weaker than normal, we're seeing that, for example, now that there's consistent suggestions from one prediction system, at least, for that to take place 4 or 5 weeks in advance. Now, it's difficult to say that there's skill in doing that, But there are certainly suggestions, and there have been occasions when just a weaker than normal vortex has been predicted several weeks to even a month before it's occurred.
And what would we look at as meteorologists to determine if the weakened polar vortex that, let's say, does unfold in December will impact the North Atlantic Oscillation? What as meteorologists should we look for in the patterns?
So one of the first components is seeing whether that warming in the stratosphere is strong and persistent and is able to get down into the lower stratosphere and weaken the circulation just above the troposphere. And so that can then start to influence the weather patterns that we see at the surface and their evolution. And then I think another one is just looking at the North Atlantic and looking if you have perhaps a blocking ridge over Scandinavia, maybe slightly further east than that, whether that is starting to kind of regress westward toward Greenland and then start to induce this pattern that's characterized as the negative North Atlantic oscillation that can then lead to cold air outbreaks. But really, diagnosing that component of it is one of the hardest parts of stratosphere-troposphere coupling science, something that's fundamentally still not well understood and very difficult to predict in practice. But the key thing is that anomaly in the lower stratosphere, is the vortex there weak and persistently weak? And that, for example, is something that we didn't see in February of 2023, and that was consistent with the fact that that warming did not drive a major impact at the surface.
Now, the Tonga explosion put plenty of moisture into the stratosphere, and from what I understand, in the southern hemisphere, because of that, the vortex was very strong during their winter and our summer. Now, is there any clues that would indicate that the polar vortex potentially could stay strong this winter in the northern hemisphere because of that influx of moisture into the stratosphere, which induce a good bit of cooling as it evaporates? Do you think that A, this will be a topic of research in the future, and B, if the Tonga explosion with the increased amount of water vapor in the stratosphere could have an implication on the status of it going through the winter?
So I think that's a question which a lot of people are thinking about, and certainly it has even been written in published journal articles that it would have a significant impact on some aspects of the vortex in Northern Hemisphere winter that we're going into now. Perhaps the most important one actually is whether it has an impact on the chemistry of the stratosphere, and it has consequences on ozone, which is obviously important to the ozone layer, is very important to life on Earth. As to whether it has an impact on the vortex strength, I think that's very difficult to say, because the vortex strength is a function of not just the mean temperature in the stratosphere, but the temperature gradient. And it's a little unclear whether that temperature difference between the pole and the equator and how that evolves with excess water vapor in the stratosphere from Hunga Tonga is really influenced in a significant enough way that the other variability that's going on in any given winter in the Northern Hemisphere that influences the vortex, whether that signal is loud enough to be detected above the rest of the noise that's going on. But what I do think is that if we were to have a situation where the vortex did, for other reasons, become unusually strong and stable, then it's possible that the air within the vortex could become a lot cooler because of the excessive long wave cooling from the water vapor. And that could have consequences for both a feedback on the strength of the vortex itself and for chemical depletion of ozone later on into the spring. So I think it's a particularly complicated topic, but one that everyone will be keenly watching through the winter.
So we had a stratospheric warming event last year, and historically, what is the chance of having a second consecutive warming in the next winter? Does that typically happen very often?
We did see it happen in February 2018 and January 2019. We saw it a few times in the 2000s. Realistically, the average rate of occurrence of these is 6 times per decade, which works out to about once every other winter. And so that's often quoted. And often because things like La Nina and El Nino switch sign, or also the stratospheric quasi-biennial oscillation, which has an influence on the frequency of sudden warmings, often because that kind of shifts sign winter to winter, you kind of sometimes think that, oh, if we've had one winter, we won't have one the other. But it never works out quite so cleanly. One thing I would say is just that we've had a lot of sudden warmings lately. I just mentioned 2018, 2019, 2021, 2023. If we were to have one in 2024, that would be quite the exceptional run of sudden warmings. And so I know it's the gambler's fallacy to argue that the past occurrence of something is a key to the future. And certainly I don't think it has any predictive capacity, but it would be remarkable if it did happen, is all I'm saying.
Yeah. Okay. Yeah, yeah, it's definitely an interesting topic. And I know that, for myself, we did our winter outlook back in September, showcasing a pretty mild winter across southern West Virginia. And I'm looking at the signals. And of course, it appears that it'll be a boom or bust type winter when it comes to snowfall. Across the mid-Atlantic. It's either going to be well below average or well above average should we have an anomalous storm. But this is one key factor in it, or one wild card would be, do we get a dump of cold air in the super El Nino winter, or does the cold air stay bottled up? And of course, the polar vortex being that wild card. So there'll be a lot of studies that come out of this winter, I think. Do you?
Yeah, I think the other process to think about is this phenomenon called stratospheric wave reflection. And these episodes typically induce a pattern characterized by the Alaskan ridge weather regime that is defined by having a ridge over Alaska and a trough downstream. And these actually bring on average the coldest weather for the eastern half of the US, not the snowiest, but the coldest. And when these patterns kind of evolve away and you bring in moisture off the, what I would say is exceptionally warm Atlantic sea surface temperatures, then you can see notable notable snow outbreaks. Now, these wave reflection episodes kind of happen involving different processes in the stratosphere. They don't require the vortex to be weak. That's one thing. An average strength vortex, or even potentially a stronger vortex, can drive these events, and they happen on much shorter timescales of around 10 days or so. So I think it's not all, we shouldn't put all our eggs in the sudden warming basket. We do have another stratospheric process to think about. And also potentially even the role of our changing climate at the surface and the exceptionally warm Atlantic surface temperatures, which in one way could moderate any cold air outbreaks that we have. But in the other sense is, if you do get the situation that is just conducive enough for snow, then because a warmer atmosphere holds more water, you could see an exceptional snow event as a result of that.